start. Let's say here, it's our module, how we load the geometry from the database. So you just put it here, and then you give different tags. It can be from different projects. You are absolutely free. And then, for example, you drop a list. And here, automatically, you have, according to your text, according to your selection, you have a different list of geometries. And then you just make it visible. We just drop here another panel so that we see the available parameters here. So what we need. And the default parameters is here, but you have two input parameters, as you can see, x1 and x2. And we just put the slider and drop it here. So then this slider is going to be changed, and then you see the deformation of the geometry. So now you see that that was x1, and then there's x2. So if you delete one, it go back to the default one according to your representation. And then as export, for example, you have this surfaces. I just reduce it, and then you set one parameter, that's like one module. And then you change somehow so you can easily publish them to your solid representation of the Rhino, and then you can export them, you can calculate, so in any possible combinations. It's up to you, and you see they are different instances, but from the same code. It's not the only functionality, because there are different types of geometry you can store, and the way how they are shared. The same model works good with the 3D scan. Of course, it's not anymore a surface. You see there's nothing is here, but it's given like a mesh here with another output. Another option that you have actually different other possibilities. I mean, this is exactly the same, and there's something for arch. For example, that could be a simple rectangular beam. Then you extrude it, or it can be a sandwich. And then, for example, if you select them, so the arch is given with some parameters, so you have a shell to make some analysis, some calculation. Then these objects are actually all the same. I mean, you have the list of parameters, but they are all based on the same principle behind. So some of them are without parameters. We can publish also some instances that are fixed. I don't know, for some reason, maybe you have some special request. So then we can publish it in this way. The I-beam, some another sample, and for example, the water bomb cell. So it takes time. And you see that before, we go to the default version. I want to show you another thing, that sometimes the Python coded library can be quite heavy and it takes time for them to run. So that's why the code works like creating external instance of the Python that is running constantly on the background. And for the codes that are created from the JSON expression, they are quite lightweight. So you can see the response is really small, so it's just milliseconds. Of course, this milliseconds can be even less if you do not have this canvas. The smallest canvas, the faster processing. If we go to the water bomb, the initial load may take a couple of seconds because it loads the library, but then afterwards, any modification is just also some milliseconds. And then we can see, for example, the first parameter, we can edit the slider. So, and then we put the minimum to 1000. I just want to say the numbers I select without any special purpose. And then if you just move the sliders, you see the response is quite fast. So you can easily play with the water bomb geometry. So basically this module covers, as far as I see, more or less all the possible formats that we use, and you have different options to code it. Either it's a 3D scan, or it's a fixed, or it's expression-based, or it's a completely Python where you have no limits of any possible libraries you want.